All right, so in the last class, we decided to make a very simple choice. We said choose left or choose right. That's great. Today, we're going to make a more thorough, yet still simple choice, in theory. We're going to add to what we can do. We're still going to be using simple selection, but we're going to add to how we can work with that. So what do I mean by that? Well, when life throws more than one variable at you, the truth is sometimes our choices are based on more than one variable. In fact, most times they are. So for example, if you decide to go to the beach, that might be based on whether it's summertime and whether it's not raining, right? You're not going to go to the beach in wintertime, and you're not going to go to the beach if it's raining. It doesn't make any sense to do so, and barring any weirdness. But anyways, so that's two variables that are dictating that choice. That definitely happens in programming as well, depending on what the situation is. In a program, we might see something like, well, I'm only going to calculate the area of this rectangle if I have both a length and a width that are positive numbers. If the user entered in a negative number for a length or a width, I don't want to calculate that because that's going to give me a bad value. We can't have a negative width or a negative length. It's not possible. Same with zero values as well, but let's just keep it simple for now. So how can we implement these choices? Well, we can do that. We can satisfy this idea of double criteria in two ways. The first way is something called nesting, and the second is something called compounding. You've probably heard both those terms before, but maybe not in the context of programming. Let's go to nesting first. So nesting, especially because we have such a large Russian population at our school, you've more than likely heard of these things before, which are Russian nesting dolls. And the idea is a smaller doll within the bigger doll, so it just keeps going smaller and smaller and smaller. So we have dolls within dolls. Well, code, we're going to be able to do the exact same thing. Nesting in code is simply the act of having control structures inside of other control structures. Now, I specifically use the term control structure and not if statements because we're going to learn more different types of control structures later on, and we can nest those things as well. So right now, we're going to have if statements inside of if statements. Great. So how do we do this? Well, there's really nothing to it. You just do it. You just have an if statement inside of an if statement. Now, of course, we need to understand a few key things in order to understand how this actually works. First of all, when the code is executing, it's going to come down and it's going to say, well, is my length greater than 0? If it's not, I'm going to skip over and keep going with the rest of the program. You notice it won't even test the width. It doesn't need to because it failed the length. So it just continues on with the rest of the program. However, if its length is greater than 0, it's going to come in and then it's going to test the width. If the width fails, again, it's going to skip out and go on the rest of the program. However, if both the length and the width are greater than 0, it will actually do the calculation. Then it will continue on with the rest of the program. Don't forget your indentation. Indentation inside of indentation. Whenever we have those set of brackets, the next piece is going to be indented. Okay, so a couple quick notes on this. You can optionally have an else statement on one, both, or none of these if statements. So for example, you might have an else statement that's designed to give the user some error information. So for example, for the inside one, you might have an else statement that says console.writeLine, you entered a bad width value. Similarly speaking, you could have one for the length as well. You could say else console.writeLine, you entered a bad length value. It gives us a little bit more flexibility and control over what the user actually sees. So this is what's called nesting. Control structures inside of control structures. Great. And as it says, as I already mentioned, the inner if statement is only ever tested if the outer if statement is true first, because it wouldn't go inside otherwise. Okay, great. What is a compound statement? First of all, you gotta remember what a compound is. Go back to your science class, your chemistry class. And a compound is something that is formed from bonding two or more items together. Typically speaking, it's two or more chemicals together, but we're going to talk in programming terms. So a compound is something that is formed from bonding two or more items together. So what we want to do is we want to create a compound if statement. That's basically saying if this is true, and if that is true, then do this action. The key word being and there. They both have to be true in order to do the action. So this is like combining two completely separate but complete comparison tests together into one statement. So I might have one that says, if x is greater than 5 and x is less than 10, do this work. Now think about that. That means it's greater than 5 and less than 10. I created a range between 5 and 10. What if I did this? What if I said, if x is greater than 5 and less than 3? Wait a second. I just created an impossible compound because a number can't be both less than 3 and greater than 5. That's not possible. So we have to be conscious of the comparisons that we're actually grouping together. Okay. So how are we going to actually compound these things? How are we going to join these things together? Well, we're going to introduce some more operators. So right now you have your arithmetic operators, your math operators. You have your comparison operators we learned in the previous lesson. Now I'm going to teach you something called Boolean operators. And Boolean operators are simply operators that work on true-false data. Okay? So simple as this. If this is true and this is true, what is the result? That's it. So let's take a look at what we have. There are 3 Boolean operators in pretty much every programming language, and in fact there are more in many more other languages, but we're going to focus just on the 3 for now. So the first one is AND. And in C# the way we do this is a double ampersand sign. And the simple truth is that the result of an AND statement is true if all the tests evaluate to true. So if x is less than 5 and x is greater than 2, that means it's between 2 and 5, any number that's 3 or 4 would be true because greater than 2, less than 5. Okay. Or means at least 1. So at least 1. It's true if at least one of the tests evaluates to true. At least one. So that means they can all evaluate to true technically. But at least one, we're good to go. We saw this already with greater than or equal to, less than or equal to. We've already seen this. And the last operator is not, which we use the exclamation mark. This one's true if the entire test is false. So basically, if it's false, we're going to get the true. Now, some of you may be saying, what are these 2 vertical lines for OR? Well, look on your keyboard. They're right above your Enter key. Okay, usually you have to hold the Shift key to grab them. So Shift and then that double vertical bar. So AND means all need to be true. OR means at least one needs to be true. Not means the whole thing needs to be false. Okay, let's break this down a little bit. Assume that we have 2 variables, x is 6 and y is 3. Now let's use these compound Boolean operators to create some statements. So the first one we're going to look at is AND, all right, double ampersand. Here's an example. If x is less than 10 and y is greater than 1, well, let's look at this. So x is 6, so is 6 less than 10? Yes. And y is greater than 1. Well, y is 3. 3 is greater than 1? Yeah, so both of those are true. So the result is true. How about OR? Is x exactly equal to 5? No, it's not. Is y exactly equal to 5? No, it's not. So it failed. If I had changed this to is y equal to 3, well, that whole statement would then be true because at least one needs to be true. And finally, not. Is x equal to y? Well, is x equal to y? Is 6 equal to 3? No. But we want the opposite of that because we're taking the not. So we get a false in here. The not of false is true. So we get a true. Not basically just flips your polarity. It flips it from true to false or false to true. That's all it does. It's like multiplying something by -1. Okay. So let's take a quick little example. You remember the code from a couple slides ago. Let me show this. This code right here with our nesting, we want to use a compound statement to show it a much cleaner way. So here's the exact same code using a compound statement. If length is greater than 0 and width is greater than 0. Notice that it's 2 completely separate comparison statements that just happen to be joined by the AND operator. Then we're going to calculate area is equal to length times width. Now some of you might be saying, well, why would you ever do nesting if you could just use compounds? Compounds is cleaner. Well, yes and no. Sometimes it depends on what you're doing. Sometimes when you have many compounds that need to happen, it's actually cleaner to use a nesting statement. It depends on the code at the time. So let's test your logic. Here is an ugly one. Let's see if you can get this. I want you to pause for a second. I want you to pull out a pencil and a piece of paper and see if you can solve this. Without coding this, tell me what the value of the result is. Imagine I have a Boolean variable called result and 3 other bools, A, B, and C, which are true, true, and false. What is the value of this statement? Now, don't forget your Bedmas orders, your brackets, and everything like that. Okay? Here's your tip. Evaluate your inner brackets first and work your way outside. Okay, I'll give you a second, and then we'll write it on here to show you how we evaluate it. Okay, so assuming you're back now, let's grab this. We will use our pen. Now I said we work from inside out. So this is as inside as we can get here. A and C. Well, A is true. C is false. True and false, well, that is a false because and means they both have to be true. So this piece is a false. All right, let's look at the next inner piece. B and not C. So B is true. Not C would be true as well. So true and true. Here we have a true. True and true is true. Okay. Let's go to get any more inner loops or inner brackets we have. A and B and C. Well, the and means that all of them need to be true. So A is true, B is true, but C is not. So this whole piece is false. Okay, let's start building it up now. If we look at this, the not of this whole thing, we got this not of this whole thing. So that means this whole thing together is actually a true. Okay. What's B? B's all by itself over here. This is a true as well. So that means if we combine this, because we have an and here, we have true and true. So that means this entire bracket, all the way to here, did I get all the brackets there? I think I did. I believe, yes, I did, is going to be a true. Okay, so we got this whole thing done, and it's a true. Going over here. We have an or statement between these two guys. False or true. Well, or means at least one. So that means that this whole chunk, oh wow, that was terrible, is going to be a true. False or true is true. Okay, now let's look at this. So we have brackets, so I guess this goes all the way to there. And this one goes all the way to there. All right, so now we have a true and a true. Well, that whole thing together then, all the way over to here, is a true. But then we got this guy right here. And it's going to take that true and make it a false. So our final answer is false. So that's how you do it. You break it down, you do the inner pieces, and then you build up. And that's how you solve for those problems. Okay? All right, so that is a test on logic. You learned how to do nesting, which means selection statements or if statements inside of if statements, and you learned how to do compounding using and, or, and not. These are going to be huge tools going forward. It's going to allow us to do things like create ranges of data, combine multiple different comparisons, but they still should be related. Obviously, they should have the same goal in mind. And that's what we're going at. Tomorrow, or the next lesson I should say, we're going to learn how to make infinite choices, more than 2.